Okay, today we're going to continue our look at probability, and we're going to look at a new concept called permutations. And a permutation is an arrangement of objects in which the order is important. For example, if we had the first three letters of the alphabet, A, B, and C, we can arrange these in a number of different ways. We can have A, B, C. We could have them as A, C, B. We could start with the letter B, B, A, C, B, C, A, or we could start with the letter C. Okay, so those are all of the different ways we could arrange the three letters. So the total number of permutations of A, B, and C would be 6. All right? Now, it's fairly easy with a small number of possible outcomes to make a list of them all, but let's say we have a few more letters than that. Let's say we've got the letters A, B, C, D, E, and F. So this time we have the first 6 letters of the alphabet. If we were to try and write all of these out, it would take us a very long time indeed. We've got A, B, C, D, E, F, then we could have A, C, B, D, E, F, A, B, D, C, E, F. It would take a very long time. So we need a different approach. Now let's think about the first position that we're going to write. We could start our our sequence of letters with any one of those 6 letters. So there are 6 possibilities for that first position in this sequence. When that first position has been decided, and it doesn't matter which letter is chosen, there are only 5 letters left. So for the second position, there are 5 possibilities. Similarly, for the third position, there's only 4 letters left. It doesn't really matter, or it doesn't matter at all what the first 2 letters chosen were. There's still only 4 letters left. So there's 4 there. For the fourth position, there are 3 possibilities. For the fifth position, there's only 2 possibilities. And for the last position, there is 1 possibility. And the total number of possible outcomes are all of these numbers multiplied together. And that's 6 times 5 times 4 times 3 times 2 times 1. And a quick visit to a calculator will tell us that that is 720. So we've saved ourselves quite a bit of work of writing out all these numbers. We would have had to write out 720 different orders of those letters to get this answer, and we've done it very, very quickly. And this particular calculation, this is called a factorial, and it's written in this way. So we would say there are 6 there are 6 items, and they're going to be arranged in any order. We would write it as 6 with an exclamation mark. And that exclamation mark means, we say 6 factorial, and what it means is 6 times 5 times 4 times 3 times 2 times 1. And that gives us 720. Let's say we've got a few more letters. Let's say we have 10 letters. So 10 factorial would be 10 times 9 times 8 times 7, etc. And we put that into our calculator. If you look on your calculator, you will find this factorial button. It's an exclamation point. Usually it's X exclamation point. Try and find that. And we do our calculation. 10 factorial gives us 3,628,800. And if we were to do all 26 letters of the alphabet, we would get a calculation that looks like this. 26 factorial is an incredibly large number, so big that it doesn't fit on our calculator and it has to be written in exponential form. And it's approximately 4.03, I'm just going to write it to 2 decimal places, times 10 to the 26. So you see that it would actually be physically impossible to do these calculations by hand, by writing out the order of these letters. If you were to try and do that with every letter of the alphabet, you would spend the rest of your life on that one problem, and you would not get even 10% into it. You would even writing one version per second, you would still take longer than there is available time left in the universe. It's an extraordinary thing to think about. Okay. So that is what a factorial is, and we use them when we try and calculate these things called permutations. I'm just going to pause this and find some examples. Okay, so let's look at this particular example. Your band has written 12 songs and plans to record 9 of them for a CD. In how many ways can you arrange the songs? Now, if this was all 12 songs, this would be an easy question to answer. It would be, there are 12 different items and you can arrange them in any order, so it would be 12 factorial. However, you're not choosing all 12, you're only choosing 9 of them. And there is a particular calculation which deals with this. And this is the formula we're going to use. So it's written in this way. NPR equals n factorial divided by n minus r factorial. Now, the two variables here, n is the total number of objects or outcomes, and r is the number chosen in this particular example. So we are choosing 9 from 12. So we would write our permutation calculation. P stands for permutation. So our permutation would be, we are choosing, we've got 12, and we are choosing 9. And so that would be 12 factorial divided by 12 minus 9 factorial. We can simplify that. So that gives us 12 factorial divided by 3 factorial. And if we calculate that, what that is, 12 factorial divided by 3 factorial equals, and I get another extremely large number, 79,833,600. Okay? So please do that calculation yourselves, so make sure that you understand the workings of your own calculator. Okay, let's choose another permutation at random. Let's say we've got a calculation something like this. Say we have 5 items, and we want to see how many ways we can arrange 3 of them. Let's say we have the word mouse, and how can you arrange 3 letters in the word mouse? We've got permutation 5, choose 3. So this would be 5 factorial over 5 minus 3 factorial, which is 5 factorial divided by 2 factorial. Do that calculation. And that gives us a total of 60. Okay? Right, we're going to work through some problems. We're going to start off on page 854, and if we could do problems 12 through 27, which I'm just going to include below. Okay, there it is. Okay, great. Now, what we're going to do now is look at how can you use permutations to calculate probabilities. So let me give you a specific example. Okay? So for a town parade, you're riding a float with your soccer team. There are 12 floats in the parade, and their order is chosen at random. Find the probability that your float is first, and the float with the school chorus is second. Now, we've got to remember what the probability is. So the probability of an event is the number of positive outcomes divided by the total number of outcomes. So we need to calculate these two things. We're going to start with the total number of outcomes first. So there are 12 floats in the parade. What is the total number of ways that these can be arranged? Well, we've already looked at this. The total number is 12 factorial. With 12 different floats, you can arrange them in 12 factorial different ways. The trickier thing is thinking about the number of positive outcomes. Now, let's think about the situation. The situation is that you want to know how many outcomes have your team first, we'll call your team A, and the school chorus is second. So those two positions are fixed, but the rest of the floats can be in any position. So you've got teams C, D, E, F, G, H, I, and J. I think that gives us, K and L. So that gives us 12. So the number of positive outcomes, the first two positions, you've already decided that you're only interested in the number of outcomes where A and B are in those two positions. So the only ones which can vary now are the rest of them, the rest of the 10 floats, which you're not particularly interested in. And the number of ways you can arrange 10 items is 10 factorial. So there we go. The probability. So the probability that team is first, chorus is second, can be written as 10 factorial divided by 12 factorial. And if we were to put that into our calculator, 10 factorial divided by 12 factorial, we get an answer of 1 over 132. And that's the solution to the problem. So we go back to the question, find the probability that your float is first and the float with the school chorus is second. The answer is 1 to 132, or 1 in 132. All right. Now these are not particularly easy problems. It can be quite tricky to work out exactly how many outcomes are the correct ones for you, the positive outcomes. Usually working out the total number of outcomes is quite easy. So I think we need quite a bit of practice in this. So we're going to be looking at the word problems, starting on page 854 and going on to the next page, 855. And I'm going to give you problems 32, 34, 35, 36, 37 and 38. Okay, work on these on your own. Again, solutions are on the rear wall. I am going to just include them in the rest of this video. When you get to them, pause, do the problem and continue. If you find one that's a bit too difficult, try one of the other ones and obviously ask me if for any assistance. Okay, here is question 32. Moving on. Question 34. Moving on. Questions 35 and 36. And lastly, question 38. Okay? Right, that's it. Once this is completed, obviously there's the homework for this unit, and then we'll move on to the next one.